Hi, yeah. So I'm going to talk a little bit about the Crystal programming language. But before we get really started, a little bit of my background is I've been doing Ruby for maybe 10 years. And so if there's any Ruby contributors or committers in the audience, thank you very much. Without Ruby, I probably would not be a programmer. I was doing something different in college, but I went to the second RailsConf, and the people I met there and the community that Ruby brought together made me really change what I would do with my career. So, 本当にありがとうございます. So Crystal, I've been using that for a little while now. It's a programming language very similar to Ruby. I wrote a Postgres driver in Crystal, and then also I've been contributing somewhat to the language, the standard library, and the compiler itself, just one commit there. Mostly the standard library. So this talk, what we're going to cover is what Crystal is, how it's similar to Ruby, and then also how it's different, and why it's pretty exciting and why I like it a lot. In general, I don't get excited about new technologies. I really like Postgres. It's been around for 20 years. Ruby has been around for quite a while. I tend to avoid new things. So it's really weird for me that I like Crystal a lot because it's so new. And so I hope to share some of why I find it exciting with you all. So first off, what is Crystal? So it's a programming language that's very similar to Ruby in the syntax and the semantics, but it is a compiled language which uses LLVM to do all the heavy lifting of the compiling and the optimizations. It has completely static types and completely static dispatch for methods. And so that means there's no runtime dynamism at all, no runtime metaprogramming. But the type system is very nice to use, and so it doesn't feel like you're fighting the type system while you're using it. It still feels very much like Ruby. And because it has a very nice macro step, the things that I normally use Ruby metaprogramming for is mostly at boot time, and defining methods, this and that, and my Ruby boot time, pushing all of that into the compile step. I don't really feel like I'm missing out on a lot of Ruby metaprogramming. And because it is compiled and it uses all of the advances that the LLVM team has been doing, the resulting programs are often very, very fast. And one thing that I also found very interesting was that it's very, very easy to link against C libraries. And we'll take a look at that later on. A quick timeline of how Crystal has progressed. The first public commit was back in 2012. The commit had already a bunch of things in it, the lexer, the parser, and so on. In 2013, it became self-hosted. And so the entire standard library, the compiler, the parser, the lexer, is all in Crystal itself. Before that, it started out as Ruby, and the Ruby would generate the LLVM instructions. But once it got sufficiently advanced enough, they ported it over to be Crystal. And this makes it very nice because as someone who, I know a little bit of C, but I'm no expert by any means. But because it is all in Crystal, it's very easy to go in and understand the standard library and understand the compiler. A little bit after that, they added the Boehm garbage collector, which is this like an off-the-shelf conservative garbage collector. It's doing okay, but I think maybe it will be replaced sometime in the future. In 2014 was the first release. Earlier this year, there's a big release where it changed all the I/O to be evented I/O, and this made a lot of like the web service stuff, extremely more performant. I got my first commit in there a little bit after that, and then currently we're on 0.9.1, and it's things are looking pretty stable, pretty good. So let's look at the similarities. As everyone here is probably a Ruby developer, a lot of this will seem extremely similar. Here we have something that shows a lot of different features. We have range syntax to make a range. The standard library methods of converting a range to an array, that's all the same. Sort, taking a block, and reject to take things out. And the ability to chain methods and so on. This code works both in Ruby and in Crystal just exactly the same. Crystal also has the same style of object-oriented programming. You have classes. You can have an initialize method. You can all the methods have implicit return. Instead you don't have to say return, and so on and so forth. All of this, it works both in Crystal and in Ruby. Again, all of the classes are open, so later on you can reopen them and redefine methods. One thing where this is really nice is if you want to mess around with things in the standard library, you can reopen them in your program and change parts of the standard library. And because the standard library is all in Crystal, there's no performance hit for doing something like that. One thing where I was playing around with this is mucking about with the hash table and making my version of the hash table have many more slots underneath to avoid having to grow it so much as I created a new hash. And then I could quickly see if that would be faster or not. And that was very nice that I could experiment with the internal workings of the standard library from my own user program. We have modules. You can extend and include them just the same. All of this, again, it's not very interesting as a Ruby programmer, but it's very interesting that this language supports it just the same. More than that, though, because the syntax is very similar, you have the same idioms. And so trailing conditionals allow you to express things in the same expressive way, do something unless you shouldn't. You have question mark methods to indicate a Boolean response. Or equals works, and so on. It includes a built-in testing library that looks a little bit like RSpec and has a runner and RSpec describe and it blocks. Having this as part of the language is very nice, and you can run all your tests. But the thing that was most interesting to me after working with it for a couple months that I didn't initially realize is that because it looks superficially the same, I can take all of my knowledge of how to structure Ruby programs, of where to put things in which files, how to break my classes up. The same skills that I've been developing over the last several years with Ruby come straightforward. Learning a syntax of a new language, that's very easy. Maybe it takes a couple days. But learning how to be effective in a language, learning the idioms, learning how to structure your programs, that's something that takes years. And because this looks so much the same, you get to take all of that experience with you, which is very, very nice. But if we just looked at the similarities, you might think this is just a compiled Ruby. But it's not true. There's lots of differences, both big and small. For example, one of the small differences is in the standard library, we are starting to get rid of all the different aliases. So in Ruby, if you have an enumerable, you can, of course, do size or count or length. In Crystal, we decided to get rid of all those aliases and just pick just size. And similarly, map and collect, we only have map. There is no collect. So that's a small difference. It's not that important, but it is a small thing. Another small difference is single quotes are characters instead of strings, and you need to use double quotes for strings. And then speaking of strings, more of a medium difference is all the strings are immutable. So whenever you operate on a string, it makes a new one. So this has at first glance looks a little bit like Ruby, but you'll notice that there are a couple differences. Instead of add or accessor, it's called property instead. But it does the same thing. It defines a getter and a setter. Similarly, getter instead of adder reader and setter instead of adder writer. One of the interesting things here is in the initialize method, and a common pattern is you take in an argument and then you just set it to be a instance variable of the same name. In Crystal, if you just use an @ sign in the front, it'll automatically do that. I tried just to more to see if I could, rather than I didn't know if it'd be accepted or not. But I tried to add this feature to Ruby, but parse.y proved too complicated for me. So I'm sorry. I got kind of far, but not far enough. And then string interpolation is the same. One of the interesting things about string interpolation is it looks like this, but under the scene it rewrites it as a string builder, and so it is very performant. So one of the things we can look at that previous thing, and because it is completely compiled ahead of time, we can get a lot of information about it. And so there's a tool built into Crystal where you can get the hierarchy, and you can look at a class, you can look at its superclasses, and you can know how much size it's going to take. Now the strings itself, their pointers elsewhere, they can be bigger, but you know that an instance of greeter is going to take up 24 bytes. And it figures out what all the instance variables are going to be even though we didn't declare our instance variables up front, it knew from the initialize method that those are going to be the two instances. And it knows through the use of the program that they're all strings. Another medium sort of difference is, of course, Ruby has symbol to proc. The Crystal one is similar, but it's a little bit different. Instead of a colon, it's a period, and it drops in place an entire. You can think of it as the actual thing. And so you can call one method just the same, but you can also start stringing methods. And so in the second example, we both reverse and upcase it. And because it's like that, we can also call methods that have parentheses. So we can, for everything in the array, we can split it apart by character, sort the characters, and then join it again. And that's very nice. You don't have to break out to the longer, more verbose block structure. You can still do it in this sort of symbol to proc thing. But of course, the biggest difference between Crystal and Ruby is the type system. So we're going to spend some time there. If we look at this here, we have a simple method that takes an argument and multiplies it by 2 using the asterisk method. So if we first pass in the number 3, we get the result 6, as you would expect. And if we say type of, we get the compiler type at that time. And the type is an int32. If we do it again with a different variable and we say hi, that gets doubled, just like in Ruby, we get hi. And the compiler type of the compile time type of that is a string. And so what's actually happening under the hood is 2 copies of this method are being generated. One that takes in an int as an argument and returns an int, and one that takes a string and returns a string. But because if you look at the program here, I'm not saying any types. It knows because both int and string have the asterisk method. If we take a slightly different example here of a method that sometimes returns an integer and sometimes returns a string, depending on what you pass in, things are a little different now. In the first case, we pass in 15. That's greater than 10, so we get 15 back out. If we ask the resulting type, send it the class method at runtime, we get int32. But when we ask the compile time type, we get a union of string and int32. And so what's happened here is that a new type was created at compile time of the union of string and int. When we pass in something that's less than 10, 1, we get the string back. If we send the class method, we get that it is a string, but the type is still the union of those 2 types. And so if we take the result of that, 15, and we multiply by 2, we get 30 as you'd expect. And because multiplication is defined on both string and int. But if we do something a little different, we try to add 15, now the program won't compile. And that's because the plus method, while it does exist on string, it only exists for adding another character or adding another string. There's no method for string plus an integer. And because even though it's an integer at runtime, at compile time, we don't know if which it's going to be, so it's the union. And so you can only call methods that are defined on every member of the union. So we think maybe we could fix this by removing the string return, only returning it if it's big enough, and returning nil otherwise. This also doesn't work. And because nil is just another type, the return type of this method, instead of being int and string, it's int and nil. And so we get a similar error message, a little bit beefed up because it's nil, and saying that there's no plus method on nil. Now, as a Ruby programmer, you've probably seen a similar error message all the time, undefined method, blah, on nil. What's nice here in Crystal is that all those sorts of nil checking is done for you at compile time without having to do anything special with your program, without having to annotate anything or say any types. You get to stop inadvertent nil propagation just as part of the type system, which is, I think that's really, really interesting. So how do you actually fix this problem? Well, what you can do is at runtime you can say, hey, program, I know for a fact that this is going to be an int32, and so you cast it there as an int32, and that drops the other types of the union, and it's only an int there. And if it isn't, then you get a runtime exception, and you can rescue that as you would any other exception. So you saw earlier that the string class did define plus, but only for a couple different arguments, not for int. And the way that they do that is with method overloading. This is sort of a contrived example, and maybe not as a user of Ruby you won't see this, but as a library author, a lot of times people want to have a nice API, and so they allow you to pass in maybe a hash or an array, and then people do reflection as the first part of that method. And this works well, but you have to do that every time it's called, and it's a little bit of a mess to look at. The same program in Crystal, you can say the types. You don't have to, but you can say the types in the arguments, and then you get one method for each of these types. And it works the same, and all of that computation of which block of code to run is done then at compile time rather than every time that you run the method. And this is the first time, in all of these Crystal examples that we've actually had to say a type. And you get a nice benefit for doing that. Another nice thing that you can do is define abstract classes and abstract methods. So if you look here is an example of a very simple inheritance where we have an animal class, we have a dog and a cat that define talk, and they have their animal sounds. Although I should have said wan, I think, for dogs and inus, wan. Yeah, I should have changed it. And then we have a person who has a getter, and then we assign them a name and a pet. And so I have a dog, and Alice has a cat. If we look at the hierarchy, it figures out that because we're passing in dogs and cats there as the pet instance variable, it figures out that it's going to be an animal plus. And the plus means it's going to take anything that inherits from animal plus animal itself. One thing that's interesting is if we comment out one of these two, and we only ever pass in dog, it knows that the only type that person's going to have as a pet is a dog. And not only that, but the entire cat class will be missing from the binary. So only the code that's used gets pulled into the binary. So we go back to the original thing, and we try and make the pet talk. Unfortunately, this program won't compile. And that's because the class that it thinks that person can have as a pet is animal plus. And you see here up in animal, we don't define a talk method. And so it's upset that it tells us that there's undefined method talk for animal, and we have an animal plus. And so the way to solve this is by saying that the animal class is an abstract class. And this is similar in several other languages, having the concept of abstract classes, and it's the same here. We promise, by saying that the class is abstract, we can't instantiate an instance of animal, and then it lets everything else work. If we wanted to be a little more, have a little more documentation as code, we could say inside the animal class define an abstract def talk, and that will make it so that all subclasses must implement a talk method, but you don't have to. So the nice thing about Crystal, one of the things that you give up is all the runtime dynamism, no metaprogramming. But the macro step lets you get a lot of those things. And so we saw in the previous example, getter that defined a way to have a getter, add a reader in Ruby. And the way that that's implemented is like this. Inside the object class, we define a macro called getter that takes one or more names. There's a little thing here where we have to check to see what type of name we get, because you can either say just the name as a raw literal, or you can say it with a symbol, or you can say it with a string. And so if it's one of those other things, it gets the raw value out. And then inside here, it just uses def and an @ sign to define those methods. And all of these are defined at compile time. And so the two examples here of class person, getter name, comma age, and then the second thing of actually doing the def and pulling out the instance variables, both of these are 100% equivalent. If you look at the resulting binary, they're exactly the same. So there's no performance reason to use one or the other, which is nice. Another interesting thing that you can do with the macro system is you can actually shell out. And so here we have a program that has a macro called build time that shells out to date, and then that value is just put literally into the program. And then we have a second, and so we put the result of that, and then we put the result of calling date at this moment in time. And so if we compile and run it right away, they're both the same. But if we wait a little bit and run that same program, then the values start to change, because the macro, it burns that in. And this is interesting. You can do any sort of thing you want. I was thinking maybe with an ORM you could, at compile time, connect to the database and pull in all the schema things, which maybe would be interesting, but also maybe would be crazy. So I mentioned at the beginning, one of the things I really thought was surprising was how easy it is to link against C libraries. So as I said, I wrote the Postgres driver, and these 9 lines, if you combine up the calls and make it smaller, these 9 lines, if you put these into a file and run it, is all you need to link against libpq, connect to your local database, execute a query, and print the result. The first line there says the link flags. Now we have a lot of types because we're defining the interface of which methods we're going to pull from libpq up. And we have to do some things to do the type mapping. But there's no ext conf, there's no C here, but this is a complete, very minimal, but complete Postgres driver. The real Postgres driver has a lot more things, of course, but this is, I think, very interesting because of how small it is. And if you build a program using this, you can see it is actually linking against libpq. And then a couple other things that all Crystal programs link against. A more complicated example is the regular expressions. There's a lot here, so we're not going to go through it line by line, of course, but Crystal links against libpcre. And there's some interesting things here where sort of in the middle, where we're calling compile on libpcre, you see in the arguments there's out error pointer. A common pattern in C libraries is to pass in a pointer and then have that be populated. That's so common that there's a little bit of a nice syntax here that'll do the work of creating that local variable with the result, and so you can do all that. And this right here is all it takes to take in a regular expression, send it to libpcre, and then tell it to study it so it compiles it. And then the capture is done later. And it's pretty nice that it can be done that small. So the way the compiler works is pretty interesting. So first there's a parse step. If you pass -s when you build something, you can see all the times that everything takes. So first is parsing and lexing the program, of course. And then there's the type inference step. This is where it figures out, before where it was either going to be just a dog or an animal plus, where it figures out if it needs to make copies of the methods, where it figures out if there's any type violations. And then we go into the third one there, CodeGen Crystal. What this does is it makes the LLVM types, it uses the LLVM functions, and starts laying things out. The next step it does in parallel of both the BC is for the LLVM bit code or byte code, and then it also puts together modules and then transforms that into assembly. And then the Clang step takes it all together and produces an executable. So one of the things, though, that's very important is you can pass the -- release flag. And what this does is enables all of the LLVM optimizations. And so this takes a lot longer. You see here, this is taking now 4 seconds instead of 0.7 seconds for the second to last step. But this makes a binary that is much, much, much faster by using all of the work that all the LLVM companies are pouring into LLVM. And so this is a simple benchmark. If you look at this Costa benchmark, they have benchmarks against lots and lots and lots of different languages. The JSON benchmark has very large JSON things and takes how long it's going to parse them. If we just run the Crystal one without the release flag, it takes 12 seconds on my machine here. But if we use the release flags, it drops it all the way down to 1.5. And so you can see that the release really is really important for having the speed. And then the Ruby test, you can see Ruby and then also with Yagil linked in. One of the things, though, that I found was surprising was because Crystal is just going straight to LLVM, all the very old tools like perf on Linux or instruments on OS X, when you go and do that for benchmarking, you get your actual symbols, your method names, rather than, if you run this on Ruby with the VM, you get mostly all the VM inner workings. This, you can see exactly what your program is doing, which is very nice. Also using, GDB or LLDB, your breakpoints work fine in your code because the only thing running is the code that you wrote in the standard library. Installing it if you're on OS 10 is very easy. You can just do it with Homebrew. If you're on something else, the instructions vary because you have to add repositories. You can check that out. And there's many more things that didn't have time to get into. For example, you saw the hierarchy tool. There's also a tool that lets you put your cursor at give it a source location, and you can find all the implementations of this. You can see if I'm inside this method, what are all the instance variables and their types. And it already has like a code formatter, like if you're familiar with Go Fumpt. The concurrency story is interesting. Currently, they're have something very much like the coroutines in Go, although currently they're only single-threaded, so you have concurrency but no parallelism yet. But that will be addressed somewhat soon before the 1.0 version. And there's already a built-in package manager that is a distributed one that looks off projects on GitHub and resolves dependencies, and much more. If you have, I'm willing to answer any questions after the talk, but thank you very much.
ではちょっと時間ありますので、誰か質問がありますか？日本語でも OK。はい。
Hi, thanks for that. It's a very interesting talk. Are there any web frameworks for Crystal, and when do you expect 1.0 to come out?
Sure. So the first one, the web ones, there are two web frameworks that I know of. One is called Moonshine, which is more of a Sinatra-like, and one is called Amethyst, which is more of a Rails-like. They're both, as with the entire ecosystem is still very young, and so I'm not sure how far along they are, but yeah, they both do exist. 1.0, I'm not sure. There's a couple big changes still going through, not so much from the. One of the things that's going through is to make bigger programs compile faster, and which is going to, when you have a class, you're going to have to say a little bit more type things. And the main contributors are taking that time to sort of take another pass at the compiler to make it, while it is easy to read now because it is in a Ruby-like language, it's kind of not commented or documented well, so they're taking some time to sort of make that more understandable. So as to when 1.0 would come out, I'm not sure. But yeah, I don't know, sorry.
次は Next. Anyone other questions? では、これはLeinweberのウィール、Leinweber Twitter ですね。いいですか？終わりましたよ。